What's up, y'all? Lesson two. So our lesson today is the source of sorts. Our goals for today, we're going to review and analyze graphs and graphical behaviors. And we're also going to determine similarities and differences among various graphs. So that's kind of like our goal today. So review here. It says write the coordinates of each point and the name, the coordinate or quadrant it is in, or the axis on which it lies. So I'll go ahead and pause the video, give it a shot, see if you can name the points, and then also determine on what quadrant it is. See if you can remember what that is as well. So pause it. I'm going to keep going, but make sure you pause it and try. So for instance, if we were looking at this right now, A, okay, if we're looking at how we're jumping by twos. And so in between 4 and 6, we would have 5. So I would say that this is going to be, A would be 5, 2, because it's landing on 2 for the y-axis, but that x is falling in between 4 and 6, which would be about a 5. So A would be 5, 2. B, because it's landing on the axis there, right? We can say it's landing on the x-axis, which because it's landing on the x is actually going to be at that point 2, 0. And so you can keep going, right? C looks like we're hitting at a positive 1 because it's in between 0 and 2. And then we're actually going down 4. So this one would be 1, negative 4. So you can continuously go. Now let's talk about the axes, right? Now, if you remember correctly, our axes start with the positive here. So A is actually in quadrant 1, and then it goes counterclockwise. So if we're working backwards here, quadrant 1 is here. So let me kind of show you back here. Okay, so we have quadrant 1 is right. Give me 1 second. Let me get my drawing tool. Quadrant 1 is here. Ooh, okay. And then 2, 3, and 4. Okay, so it kind of works backwards that way. But yeah, so let's keep going here. Hopefully that gave you a better idea of what we're trying to accomplish here. So we're going to kind of identify graphical behaviors. So let's start with this one here. Matthew grouped these graphs together, and we're going to try to figure out why do we think these are graphed together. So take a second, maybe think about what we already know about coordinate grids, and then as well as what we're already looking at as far as quadrants. So you can kind of take a look here. But I'm hoping automatically you're kind of seeing that every single one of these graphs are looking at characteristics of their graphs aren't connected, right? We have points. We do have a name for that, and that is called a discrete graph, okay? I won't talk to you about that right now because you will get a definition on this in just a second, but that would be called a discrete graph when you don't have a line connecting them. So for instance, if we were to scroll down here, this one right here has a direct line, whereas, for instance, these ones are just points that are showing a pattern. Okay, so that's why I would say these are graphed together. Now, if you keep looking, right, Ashley has put some together as well. And we're like, okay, why did she put these together? Well, if you're looking, these all have vertical lines of symmetry, which means the left side is going to match up exactly the same as the right side. And so what she's showing here is Ashley is actually able to draw a line. That's that bold orange line here. She's able to draw a line between each pieces of her graph, and it's going to match exactly the same on the left as far as the right. That's a vertical line of symmetry. We could also get a horizontal line of symmetry when you can cut a line down and it has it matching above as far as below. So left to right, if you're able to cut your graph in half, and the up or above that line and below that line matches, that's horizontal line of symmetry. Okay. So now we can look at Judy here. Judy grouped these graphs together, and we're trying to figure out, okay, why are these graphed together? Because, there's no vertical line of symmetry. It doesn't look like you can do a horizontal line of symmetry. We could say that they aren't dots, right? It looks like they all have a continuous line. So we could say that. There's actually another reason why she graphed these, and she graphed these together because it actually is not a function. None of these are functions. And so we're going to kind of talk about what determines a function and not a function in just a second, okay? So, thinking about that idea, okay, we'll talk about all that in the next lesson, but I just want you to think about the idea of, vertical, non-vertical, and having all these different characteristics of um, how to look at characteristics of a graph. All right. Now,